Okay, Joe.
Yeah.
Okay, yeah, we will start our new course on algebraic geometry. Okay.
Okay.
Especially we will look at today. We will look at the conic sections. Okay.
Okay.
Okay. Let me share my board. Okay. We know that conic sections are the sections of a cone.
Yeah.
Right, from our school days.
Yes.
Remember? Okay. That fact was actually discovered by ancient Greeks. They are the first one to recognize that when you intersect a plane with a cone, you will get certain curves on that plane. Those
Okay.
planes were they named it as the sections of cone. That's why these curves are known as conic sections.
Okay.
But that kind of approach is purely geometric, purely physical. But
Okay.
today we will be exploring deeply into the algebraic side of that geometric object.
So
Yes.
algebraic geometry is explaining different geometries through algebra.
No. Algebraic geometry means I'll explain it on the way. Okay.
Okay.
Can you see the board?
Yeah, I can.
Okay. Algebraic geometry. No. Let me write conic sections.
Okay.
Conic sections. Conic sections over the reals. Over
Okay.
the real numbers. Okay, Joe, you know me. You know that I have my reservations with these so-called real numbers. But let's
Okay.
forget that. In this context, it's okay. Okay.
Okay.
Okay, I'll explain that in later. Okay. Anyway, we will be looking at conic sections over the reals. We know that the famous conic what are the conic sections, Joe?
So as you said earlier, we have different when we use a plane to cut or interact with a cone, we will get certain shapes like we can say ellipse,
Okay, ellipse. Okay,
hyperbola,
wait, I'll write it down. Ellipse. What's the equation of an ellipse?
x square plus x square over a square
X squared over x squared,
plus y square over b square
y squared over b squared
is equal to some
equal to 1.
1 or
Okay, the a is known as the semi-major axis and b is called the semi-minor axis. Okay, then we have the parabola.
Yeah, parabola is y square is equal to 4x.
Or y equal for ax squared, or it can be depends on
Yeah,
the
yeah,
orientation.
it depends how we define. Yeah, y is equal to
It depends
4x.
on which axis is the parabola open. Okay.
Open to, okay.
For instance, if y equals ax squared, we know that that curve will be ax squared. That curve will be like this.
Yeah.
Okay. Let's not get too deep into the geometric aspect. Let's focus on the algebraic side. Okay. Next, what is the hyperbola? We know the curve hyperbola. Do you remember the equation?
Yeah, it's x square over a square
Okay,
minus
I'll write it here. Hyperbola x squared
over a square
over a squared
minus y squared over b square is equal to 1.
It's 1, yeah, because you have to just change the plus sign into minus in the equation of an ellipse.
Yeah.
Okay, then we have the circle, which is in fact an ellipse.
Yeah.
Okay,
Ellipse with a and b equal to r.
Equal to r, exactly. So we get x squared or 1 or x squared plus y squared equal to 1.
Is equal to 1.
1. So this is a unit circle, meaning the radius
Yeah.
is a unity. Okay, circle. Okay, if you observe all these equations, you can see the pattern, right? Because all these variables has the power 2.
Yeah.
Except this y. Okay.
Yeah.
So that is the maximum power of the variable in all of these equations is 2.
Yeah.
Why is that? That is because all of these equations are particular cases of a general quadratic equation 2 variable.
Okay.
Okay, so all of these equations. That let me write that equation. The general quadratic equation in 2 variable. That's ax squared plus by squared plus ax squared plus bxy plus cy squared plus dx plus ey plus h equal to 0. Okay.
Okay.
Okay. If we put like I don't know, like a equal to 1, b equal to 0, then c equal to 1, then d equals e equal to 0, and h equal to 1, h equal to -1, we get the equation of a circle, meaning 1 x squared plus 1 y squared minus 1 equal to 0,
Okay.
or x squared plus y squared equal to 1. Similarly, depending on various values of these coefficients, we can arrive at various equations of these conics. Okay.
Okay.
Okay, meaning all of these conics are essentially the same equation with the different values of this conic, the values of this coefficient.
Okay. So
Okay,
Ax.
that's why conic sections are also known as quadratic curves.
Okay.
Quadratic curves. Okay.
All right.
Okay. Then
So it's
okay.
so the equation is ax square plus by square, isn't it? Or bxy.
bxy
Okay, bxy plus cy squared plus dx plus ey plus f or
plus
h.
f
Okay.
or h. I usually use h.
Okay. Equal to
Okay.
0. Yeah. Okay.
Okay. Now, what I have written here that we are studying conic sections over the real numbers. What does that mean? That means that these variables x and y should only have real values.
Okay.
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 Okay. Now, first of all, note that this is not a polynomial. This is an equation. So this equation does have solutions. Okay. The solutions of
Okay.
these equations are values of x and y that satisfy these
Oh,
equations. Correct.
yes.
And that values of the values of x and y should always be a real value, real number.
Okay.
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 Or if you are more computationally oriented, you can say a rational number. Okay.
Okay.
In fact, actually the correct answer is a rational number. You cannot multiply two real numbers. How can you multiply an infinite decimal? It's not possible. But let's say for colloquial in colloquial terms, we are just calling it the reals. Okay.
Okay.
Let us not be too critical. Okay, it doesn't serve our purpose here. Okay.
Okay.
Okay, now, so we want to find the solutions of these curves for various values of these for these coefficients. Okay,
Okay.
so how do you solve? We proceed by converting this equation into an equation with in x, meaning we
Okay.
can write it as ax squared plus taking x common will give you by plus d times x plus cy squared plus ey plus h equal to 0.
Okay.
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 Okay, name this a as capital A, name this by plus d as capital B, this term as y c.
Okay.
Then what will be
1
the
minute, let me write that. Plus c, so you will get cy square, yeah, you will get x square plus, so all the terms containing c only cy square plus ey plus h will be c, capital C, isn't it? So this is capital A, and by plus d will be capital B, and cy ey will be capital C. Yeah. Okay, so x will be b square minus 4ac divided by 2a, isn't it?
x will
X
be what?
b sorry, minus b plus or minus capital B plus or minus root of b
No, Joe,
square.
just write the equation. What will be the equation?
Yeah,
Ax squared, capital A times x squared
yeah,
plus
plus
capital B
b,
times x plus
yeah,
c equals
0.
okay 0. Okay, now we have got a solvable equation. We know how to
Yeah,
solve this equation.
yeah,
But remember, these b and c are not constants; they are functions of y.
from,
But a is a
okay,
constant.
yeah,
Okay, but this is an this looks like an equation in x, but actually it's not an equation in x, but this is an rearranged form.
yeah.
Okay, so what will be the solution?
We can use that equation,
Quadratic formula.
quadratic formula. Yeah,
To find x equals minus b plus or minus square root of b squared minus 4 times ac over 2a.
yes,
Okay,
over 2 times a. Yes,
where b equals by plus d and a equals a, c equals cy squared plus ey plus h.
yes,
Okay, we have already assumed that we have already fixed that we are working over the real numbers, meaning the x and y are always real.
yes.
Okay,
Okay, so
so if we want x to be real, what is the condition here?
b square minus 4ac should be greater than 0, or b square should be greater than 4ac.
I mean, b square minus 4ac should be greater than or equal to 0.
Yeah, greater than or equal to 0. Yes.
Okay, that is b squared minus 4 times ac is greater than or equal to 0.
Yes.
Okay, first let's just wait a minute. Okay, let me give a short. Actually, I actually wanted to talk to you about this at the beginning of the course. What are we actually trying to do through this course? What is our mission? Okay, I want this course to have actually two parts. The first part
Okay.
should be the geometry, the Algebraic geometry of conic sections in a plane.
Okay.
Okay, in particular in an affine plane. Okay. For instance, like the Cartesian coordinate system or something like that.
Okay.
Okay. And the next part, I want this course to move from a usual plane to something known as a projective plane.
Okay.
Okay. Okay. So first, in this, what we are doing is, let me talk about projective plane later. But now we are actually concerned with conic sections in a plane.
Okay.
In a usual plane.
Okay.
Okay, affine plane means there is a you can do affine transformations, like you can squeeze or you can translate. Okay, those kinds
Okay,
of
let's talk about that later, because I don't know what affine plane or affine transformations are. So
okay.
only,
But we are actually concerned with conic sections in a plane now.
yeah.
But we eventually want to extend our theory into a more very not general, I would not say that general, but very interesting space called the projective space.
Okay.
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 Okay. Now we know that the x is real, so our b squared minus 4ac should always be greater than 0. Let me name this discriminant as delta.
Okay.
Delta of equation. This is an equation in x, correct?
Yeah.
So let me name this as an delta x. But we know that b and c are functions of y.
Yeah.
So the discriminant is actually a function of y.
Function
It's
of
not
what?
a,
Yeah.
okay.
That's what I was thinking. Yeah.
B squared minus 4ac. Well, I have named it as delta x of y. Okay, and that should be greater than or equal to 0.
Okay.
Okay, what will be what is that discriminant? Let's find out. Okay, we know b equals by plus d. So we have by plus d whole squared
plus d the whole squared plus 4 into
plus plus it's not plus, it's not plus, it's minus
plus 4 into
no plus, it's not plus, it's minus. B squared by
minus
plus
4
minus
into
4 times a times cy squared plus ey plus h. Okay,
ey plus h. Yeah.
this should be greater than or equal to 0.
Greater than or equal to 0. Yeah.
This is the delta x of y. Okay.
Okay.
Okay. Square. Expand these terms. What will you get? B squared y squared plus d squared plus 2byd. Correct. 2byd.
Yeah.
Minus 4a cy
squared minus 4e aey minus 4ah greater than or equal to 0.
Okay. Now collect the
Similar terms.
No, I mean in powers of y.
Yeah.
Okay.
So this will be b square minus 4ac y squared, isn't it? Yeah. Plus 2bd minus 4a e y plus d square minus 4h. Am I right?
Okay. This should be greater than or equal to 0.
Equal to 0. Yeah.
Okay. Now look at this. This is another quadratic equation in
Equation.
y.
Yeah.
But this time all of these coefficients are constants.
Yeah.
So this is just a usual quadratic equation.
Okay.
Okay.
All right.
And this should be greater than or equal to 0.
Yeah.
Okay. Now we know that let's look at a usual quadratic equation like ax squared plus bx plus c equal to 0.
Yeah.
Okay, just a usual equation. Okay, if a equals 0, meaning the coefficient of the leading term equals 0, the equation will no longer be a quadratic equation.
Yeah.
Okay? Then the equation just becomes a straight line.
Yeah.
Okay.
Yes.
Okay. But here is the leading term of the coefficient of the leading term, meaning the b squared minus 4ac. Will it be 0?
B square, it will depend upon the value of a, b, and c, isn't it?
Exactly, because we just took a general equation, correct?
Yeah.
We haven't placed any constraints on this equation.
Yes.
So if we take if we assign particular values for b, a, and c, such that b squared is equal to 4 times ac, then b squared minus 4ac can become 0.
0. Yeah.
Okay, in that case, the equation will actually become a linear equation.
Yes.
Okay, but b square minus 4ac can also be not equal to 0. It can be positive number, it can be negative number, it can be 0. That all depends on the values of these coefficients.
Yes.
Okay.
Yes.
And the value of this leading term actually determines what conic section is that what conic sections is being formed.
Okay, so
Okay.
value of b square minus 4ac will determine.
Let me show
Yeah.
you. Let me give some proofs. But you have to understand that this is a very important term in the study of conic sections.
Okay.
Okay. So first, let's assume that b square minus 4ac is equal to 0.
Okay.
Okay. Then we will study what will have what kind of conic sections is being formed as a result. Then we will look at b square minus 4ac less than 0.
Okay.
Okay, then we will look at b square minus 4 is greater than 0. Each of these situations, we get different types of conic sections. That is actually new kind of classification.
Okay.
If you remember from our school days, we know that the conic sections are classified using a number known as eccentricity.
Eccentricity, yeah.
If eccentricity is less than 1, it is an ellipse. If you remember it, if eccentricity is less than 1, this is an ellipse. Eccentricity.
Yeah.
Eccentricity. So it is an ellipse. If eccentricity equal to 1, we will get a parabola. If eccentricity is greater than 1, we will get a hyperbola. If eccentricity is less than 1 and if eccentricity is 0 is still less than 1, correct?
Yeah.
We will get a circle. That is why circle is also an ellipse.
Ellipse, yeah.
Okay, if eccentricity equal to 0, we will get a circle. Okay, let's concentrate on these three. Okay, but here we are being faced with pure algebraic expressions.
Okay.
We haven't actually talked about what are conic sections even. We haven't even touched upon that.
Yeah.
What do these curves look like? We actually don't know. We are just following the algebra behind a general second degree quadratic equation.
Okay.
Okay. We have just done some manipulations and we have arrived at this equation.
Okay.
And we also we have imposed a condition that x and y should always be real.
Really?
Okay. That condition is this inequality. Okay.
Yeah.
Okay, so let's first assume that b squared minus 4ac is equal to 0.
Okay.
4ac is for case 1. Case 1. Okay. b squared minus 4ac is equal to 0. Then our discriminant will become delta x of y equals Joe.
Yeah, let's look at this. Delta x of y will be equal to 2bd minus 4ae, the whole multiplied by y, plus d square minus 4ah, which should be greater than or equal to 0.
Times y plus b squared minus 4ah should greater than or equal to 0. So if we solve for y, what will be the inequality? Y.
1 minute. Yeah, y should be equal. 1 second. So you will get y should be equal to.
It's not inequality.
It should be greater than or equal to 4ah minus d squared over 2bd minus 4ae. Am I right?
Okay. 4ah minus d square over 2bd minus 4a. Okay, that is y should always be greater than 4ah minus d square by 2bd minus 4a. This is the first the condition for the x to be real in the first case where b square minus 4 is equal to 0.
Yeah.
Okay, if you look at this equation, what is this equation? Okay, if you look at this term, just look at this term. What is this?
I don't understand. 1 minute.
Okay, I'll write it down. Delta x of y equals 2bd minus 4ae times y plus d squared minus 4h. Okay.
Okay.
This actually looks like y equals mx plus c.
Yeah.
Okay. Or like f of y equals my plus c, something like that. Okay. Correct.
Yeah.
Where m is the slope of the straight line, c is the y-intercept.
Yes.
Meaning if we plot y and delta x of y, we will get a straight line.
Okay. Yeah.
That is the y delta x of y plot is a line. Okay.
Okay. So we have to think it as m. This as
So, okay.
c.
Let me
Okay.
draw a graph like this. Okay. This is y and this is delta x of y. Okay. So we will get a curve something like this. Okay.
Okay.
So this is the y-intercept. What's y-intercept? What's c? Here. What's d squared minus 4h? Okay.
Yeah.
D squared minus 4h. Okay.
So if yeah, d
Okay.
squared minus 4h.
Okay. By looking at the graph, can you say which region is the delta xy greater than or equal to 0? So that's the condition, correct?
Yeah.
Which region of the graph will give us a positive or a non-negative value for delta x of y?
Let me just check. 1 second. All right. Okay. Could you draw it? 1 second. Is yeah, the positive side from.
Meaning from this point onwards to the right.
Yeah.
Okay, this is the point where the delta x of y is equal to 0.
0. Yeah.
Okay, what will be that point? We can find from this equation.
Yeah.
What's the equation? For what? Which point will it be 0? This will be 0 when y equals this number.
Yeah.
Correct?
Yeah.
Meaning y equals 4h minus d squared. This is y equals 4h minus d squared or 2bd minus 4a. 2bd minus 4a. Okay.
Okay. 1 second. Let me understand this once again. So you will get yeah y is equal to 4h. Yeah, from this point onwards you will get from this point towards to the right you will have y as positive. Yes.
Actually, that if we this condition actually says that y should be greater than or equal to
Yeah.
this number.
Yeah.
Okay, and that number is will be here. And when y is greater than this number, meaning from this point here, we will get the delta xy greater than 0, and that
Yeah.
can be seen from the graph. Okay.
Yes.
If
Yes.
this is the condition, the conic section we get will be a parabola. That is the idea.
Okay.
In this case, the conic will be a parabola. Okay.
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 So when y is greater than or equal to, so
No. When y actually when the b squared when b squared minus 4ac
or
is
AC is
0 in the
equal to
discriminant,
0.
and x and y is already it should be real, so
Yeah.
we get this condition, and under that condition the conic section will be a parabola. I'll show it to you, but that's I have just written the statement. Okay, I'll give the proof.
Okay.
Okay, what was our initial equation of the conic section? It is x equals minus b plus or minus square root of delta x of y, correct?
Yeah.
Over 2a.
Yeah, all things are capital, isn't it?
Yes, that was our original equation.
Yeah.
We just did some substitutions.
Yeah.
Okay.
Okay.
Joe, are you following? Is there any?
Yeah. No. I am following.
Okay. Should we take a pause and just?
No. You can carry on.
You have any anime to watch later?
No.
Okay. Okay. This is the condition. This is
Yeah.
this just I just rewrote that equation. Okay.
Yeah.
So if we multiply if we rearrange this, what will 2ax equals minus b plus or minus square root of delta x of y. Okay.
Yeah.
If we so then what will get 2ax plus b equals square plus or minus square root of delta x of y. Okay.
Yes. Yeah.
If we square on both sides, we will get
Okay. X of y will be equal to 2ax plus b the whole squared. So that will be equal to 4a squared x squared plus b squared plus b squared plus 2ax times b.
2 times 2ax times b. That is
Yeah, 4x.
4abx.
Yeah, 4abx.
Okay, we know that a is just a. Here a is a, and b equals by plus d,
Yeah.
and c equals cy squared plus dy plus h or something like. What was d c? What was capital C? Cy squared plus ey plus h. Correct.
Okay.
Cy squared plus ey plus h. Ey plus h. So we will get 4 times a small a squared times x squared plus by plus c whole squared, b squared y squared plus c squared plus 2byc.
Yeah.
dy plus d. This is dy plus d plus d squared plus 2byd plus a times
4
4a
times
4a times by plus d
plus b times x.
equals delta x of y.
Yeah.
Okay. So okay, let's write what's delta x of y. What is delta x of y?
We have found it earlier. 2bd. So here b 2bd minus 4ac times y.
Exactly, because we have assumed that b squared minus 4ac is 0.
Yeah.
Okay.
Yeah.
And we have to show that what we will get will be what the curve we are getting. The curve we are getting will be a parabola.
Parabola. Okay.
Okay, that's what we want to show. So since b square minus 4ac equals 0, we can write it as 2bd 2bd minus 4ae times y plus plus d squared minus 4h.
Yeah, d squared minus 4h.
Okay.
Is equal to 4a square h squared plus b squared y squared.
A squared x squared plus b squared y squared plus
d
2b dy
squared plus 2.
plus d squared plus 2byd or bdy or some bdy plus 4aby. Correct? No. Let me look at my notes for 4. There is an x here. I just missed an x here. Okay. 4a. Okay, let me write it as 2 times 2ax.
Okay.
Times by plus 2 times 2ax times d.
Yes.
Which is actually 4axd. 4
Yeah.
a dx.
Okay.
Equals if you multiply y, if you distribute y here, we will get it 2b dy equals 4aey. No, not minus. It's just minus 4aey plus d squared minus 4h.
Yes.
Okay. Okay. Then we can cancel. What terms will get cancelled?
1 minute. Let me write. 4x squared plus b squared y squared plus b squared plus 2b dy on both sides will cancel.
Yes, 2b dy will cancel then.
Then there is nothing else. 1 second.
There is d square on both terms, both sides.
Yeah, d squared on both sides. Yeah.
Okay, then we can write it as 4a squared x squared. We can write as 2ax whole squared.
Yes.
Okay, plus by whole squared. Okay.
1 second. 1 second. So you will get negative 4aey minus 4a.
Negative 4a. Negative 4ay is on the RHS.
Yeah. 1 second. Oh yeah, 2ax the whole squared. Yes, plus by the whole squared plus
2 times
2bdy.
2ax and
Okay. Yeah. Got it. 2 times 2ax into
times
by.
by.
Yeah.
Okay, plus 4 adx.
4adx. 1
4
second.
adx. 4 adx.
Okay. There is 2bdy also, isn't it? That we cancelled. That was cancelled. Yeah. Yes.
4
So this.
adx. 4 adx plus 4 aey.
Yeah.
Because let's move all the terms to one side.
Okay.
So we'll get to 4 adx plus 4 aey. 4 aey plus
4ah.
4 plus 4h plus 4 times h. 4h equals 0.
Yes.
Okay, these terms can be combined. This is a binomial expansion. Okay.
Yeah. Yes, these terms can be combined. So you will get 2ax plus by the whole squared plus 4 You can take 4a common.
Okay, 4a. That's a very, very good idea. I haven't, Joe, I haven't thought about it. That's a very, very interesting idea. You know why?
Dx minus plus ey.
You know why that's a good, great idea?
You will get a line here.
No, no, no,
I
no.
don't.
Just write down. 4a. If you take 4a, Joe, I haven't thought about it. Actually, I haven't even written in my notes. It's a great idea. 4a. If you take 4a common, we will get dx plus ey plus h equals 0.
Yeah.
Okay.
Yes.
If no, 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 okay, okay. If we just move this to the
Other side.
arches, what will be the equation? 2ax plus by whole squared equals minus 4a times dx plus ey plus h equals just h.
Yeah.
Okay.
Okay.
Okay, this actually looks like y squared equals minus 4ax.
Yes.
What is this?
Okay. So you are calling 2ax plus by as y.
No, 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 I'm not calling y. Just this just looks like this form.
Yeah, it's a
Okay.
parabola.
Yes, that's it. But here we have both x and y terms combined.
Yeah.
That is because this is a general equation of a parabola, meaning the parabola can be like
Yeah. Okay. Okay.
okay,
Somewhere in space or something like
like
that.
like this.
Yeah, it's not centered around anything.
Okay.
Yeah.
Depending if we put the values if a equal 0, no, a cannot be 0. If uh, b equals 0 or some coefficients can be made, and so we will get a standard equation of parabola like x squared equal 4ay or
Okay. Okay.
okay. That
Okay.
all depends on the value of a, b, e, d and h. Okay.
Okay.
Okay, this is still a standard equation, but not like this. Okay, this is the equation of a general parabola oriented. The orientation depends on the values of these coefficients.
Okay.
This is the equation of equation of a general parabola. Okay.
Okay.
Okay, I have I'll give you an important idea to recognize a general parabola. Let's write it as a remark.
Okay.
Uh, in a parabola, that's because I have just I have written that remark in my note. In a parabola,
Okay.
all the second degree terms in the equation, all the second degree
Yeah. Degree
terms
terms.
in the equation
Mm-hmm.
f of x comma y equals 0, meaning the equation in this equation hmm,
Mm-hmm.
forms a perfect square. Perfect square, meaning all of these second degree terms, ax squared, y squared, these terms form a perfect square, and that perfect square is this term,
Ax 2ax plus by.
whole square. That's a perfect square, correct?
Yeah.
Okay. That term consists of x squared and y squared, meaning the second degree terms.
Okay.
That's how you can identify an equation of a parabola.
Okay.
Okay. Okay,
Okay.
Joe, just let's take a pause and just you just recollect what we have
Okay.
studied. Take your time.
One
Take your
second.
time. Just recall
One
all
second.
the
One second.
ideas.
Let me just.
Logically connect these ideas.
Getting it. So if then we can say B is okay. It will determine what type of conic section is formed will depend upon the determinant.
Exactly.
So if b square minus 4 delta x of y is less than 0, you will get another conic. If it is greater than y, you will get another conic ellipse or something like that.
What are you talking about? This delta x of y?
Yeah.
No, this delta x of y should always be greater than 0
No.
because
Oh, okay, okay. Yeah, yeah. It should always be greater
okay,
than.
this
Oh,
is
yeah.
the this leading
Determinant
point.
of the determinant. Determinant of the determinant.
Exactly. It's not determinant.
B
It's
square minus
discriminant.
4 is
It's
discriminant.
discriminant. Discriminant.
Discriminant.
Discriminant
Okay.
of the discriminant.
Discriminant.
Okay.
Yeah. So how is
You can
it
also
connected to the?
call it as discriminant squared.
Okay. So how is it connected to the eccentricity? So we'll say eccentricity is equal to 0 is a parabola. So are we talking about b square minus 4ac itself is equal to e or something like that?
No.
Okay.
Eccentricity can be derived from the
Semi.
the derived from the equation of the conic itself. For instance, like if we are considering like an ellipse like x squared over.
A
Okay,
square.
first of all, I'll talk about this. We haven't still. I haven't still answered your first question. What is
Yeah.
algebraic geometry?
Yeah.
Okay, I'll get into that matter. But
Mm.
okay, consider just an ellipse like x squared over a squared plus y squared over b squared equal to 1. Okay,
Okay.
we can actually rewrite what is this a and b.
Semi-major and
Same
semi-minor.
matter. We can actually write this equation as x squared over a squared plus y squared. Okay, I'll write it down here. This is an important point. Okay, you have asked me how is question by Jonan QJ. Okay, how is eccentricity
Defines a conic.
eccentricity which is a geometric parameter. Okay, this is
Yeah.
which is a geometric parameter connected to the uh, algebraic structure of the conic.
Okay.
Okay, in essence, that's your question, correct?
Yes.
How is eccentricity, which is in fact a geometric parameter? It is a ratio. I'll
Yeah.
talk about that. But how is it connected to the algebraic structure? We know that. Okay, let's take example. We'll take an example of an ellipse like x squared over a squared plus y squared over b squared equal to 1.
Okay.
Okay, we can actually rewrite this equation in terms of eccentricity as x squared by a squared plus y squared over a squared times no 1 minus e squared, yeah, exactly, equal to 1.
Okay.
Okay,
Okay.
there is a derivation long proof for this equation. Okay, that's bit geometrical. Okay, I'm not getting into that proof, but we can rewrite this equation as this form, meaning we have b squared can be written as a squared times 1 minus e squared.
Yeah.
From this we will get b squared over a squared uh, equal 1 minus e squared, or E squared equals 1 minus B squared by A squared. So E equals square root of positive square root, because it's a ratio, it's a number, positive number. It's a ratio of lengths, so it should be positive, plus square root of 1 minus B squared over A squared. This is the formula of eccentricity of an ellipse in terms of A and B.
All right.
Okay. It is not actually based on, I mean, it's not B squared minus 4AC.
Yeah.
Okay.
Okay.
This eccentricities can be found out from the equation as, rewriting this equation as this.
Okay. So how can we derive y square is
Okay,
equal to
okay, just
4?
let me touch on another point. What is eccentricity? What is that number? It is purely geometric, not algebraic geometric. It's purely geometric. Eccentricity is for every conic. There is two important geometric objects for every conic. For instance, for a parabola, say for a parabola, we have a parabola here. Okay. For every conic, there is a line and a point.
Okay, yeah.
That line is called
Directrix.
Directrix. And
And the
that point
point
is
is
called,
focus.
correct, that point is called focus. Okay. At each point, if we take the perpendicular distance from the directrix, like this, let me call it M, this point M, this point P, which is the point on the conic itself. Then let me call the focus F. Okay. At
MP plus
each point,
P.
no, the ratio PM over PF will be a constant.
Okay, that constant is eccentricity.
Exactly. That is why I call eccentricity is a geometric thing.
Okay.
Okay. For a parabola, in this case, PM will always be equal to PF.
Okay.
That is why eccentricity is 1. For hyperbola, this eccentricity will be greater than 1. For ellipse, or eccentricity will be less than 1.
Yes.
Okay.
Yeah.
Okay. Any questions, Joe?
No.
That's a very interesting question. Okay. You should ask
And
this kind of questions so that we can dig deeper into this
yeah.
conic section.
So so you said that we have an equation for 2ax plus by squared is equal to negative 4a dx ey. So how can we derive y square is equal to 4x from here?
Y
Can just
square, what equation?
can we reduce this equation to y square is equal for the
This
parabola you
equation.
have? Yeah.
Okay, we can. Okay, that is a good question. We can. Okay, that is a really interesting question. For an. Okay, let me write. That's a very good question. Actually, you got me there, Joe. Okay. 2ax plus by 2ax plus by. What's that equation, Joe? 2x plus by
2
whole square
is equal to negative 4a times dx plus ey plus h.
plus h. Okay. Let me. Okay, Joe's second question. Okay. Another question by Joe. How can we reduce the following equation, meaning this equation, equation into a standard form? Standard form of a parabola. Okay. Okay, this equation. Joe.
Yes.
Okay, first of all, let me, put what happens if we put b equals 0, then
Y will become
then d equal to 0, then h equal to 0, okay, e equal to 1, e equal to 1, okay, put these values, e equal to 1,
okay. B, okay, what are the values? B is equal to 0,
0,
D is equal to 0,
0, h
E,
equal to
H
1,
is equal to 0. E equal to 1, okay, and H equal to 0, isn't it?
yes.
Okay, so then we will get 2ax the whole squared is equal to negative 4a into ey. Okay.
What
Yeah.
ay.
Negative, yeah.
Okay.
AEY.
Okay. So we will get
Yeah, we will
y
get
equals 4a squared x squared over 4. No, e equal to 1, correct? E equal to 1.
yeah.
So 4a squared x squared over minus 4a.
Yeah.
We will get y is equal to minus ax squared. This is standard. Okay.
Y is equal to negative a squared x squared.
Okay. If a is negative, it will be y equal to x squared positive.
But a cannot be. Oh yeah.
A can
is
be
negative.
a is
Yeah.
actually the coefficient of the general second degree equation.
Yeah.
It can be anything. Any real number, meaning rational number.
Okay.
Okay, Joe.
Yeah.
Okay, this is actually a detour from our discussion. So
Yeah.
I'll make it in a box or something like that. This is a geometric discussion. Okay. Okay, Joe. Okay, let me come to your first initial doubt. What is algebraic geometry? What is it? Okay, algebraic geometry is actually okay. What is a conic section? Is a curve, correct?
Yeah.
A curve is a geometric object. Okay.
Yeah.
A Joe's another question. What is algebraic geometry? What is algebraic geometry? Very important question. Okay. A curve is a geometric object.
Okay.
Curve is a geometric object. An equation is an algebraic object.
Yeah.
An equation is an algebraic object.
Okay.
Okay. For instance, an equation like 2x plus 3 equals 7. Okay. What is the solution here?
2.
2x equals 4. So x equals 2. Okay. Okay.
Yeah.
The solution here is a number. This is a number.
Yeah.
This is a number. Okay. An equation is not just purely an algebraic object. A number is an algebraic object. We can do algebra with numbers. We can add and multiply with numbers. This is a number, an algebraic object. An equation is made up of numbers.
Yes.
Okay, it's not exactly an algebraic thing or algebraic entity. It is made up of its equation is
made up of algebraic object, you can say.
Made up of. These are not exactly mathematical definitions. These are naive terms, but these are based on intuitions, like mathematical ideas. An equation is made up of algebraic objects.
Okay.
Objects, meaning objects that can be added. Objects. Objects
that
can be added or multiplied. Multiplied. Okay, subtraction is addition with a negative number.
Yeah.
Okay, that is actually an addition. Okay. Okay, example this equation, we got the solution, and solution is a number, an algebraic object.
Yeah.
Okay. Algebraic object.
Okay.
Okay, but what is the solution of this equation?
It's a circle. It's a group of points.
It is a curve.
Yeah, it's a group
what
of
is
points.
A curve?
It's a group of points. Geometric. Oh yeah, geometric.
Okay, an algebraic equation whose solution is not an algebraic object, but a geometric object.
Yeah.
That is the essence of algebraic geometry.
Okay,
we are dealing with algebraic equation that gives rise
to a curve.
Algebraic objects like a curve or surface or
geometric object.
Okay, geometric objects. Okay.
Like a curve or a volume or some surface.
Here the solution is an algebraic.
No. It's not an algebraic, geometric object.
Geometric object. Okay. Meaning algebraic geometry is actually algebra resulting in geometry.
Yeah. Okay.
And oftentimes geometry can result in algebra also.
Okay.
The study of conic sections is an example of geometry resulting in algebra, because conic sections were first studied geometrically. Then people dug up into the algebraic underpinnings of that subject and found out that these kind of equations and these discriminants and numbers, like algebraic numbers, playing a significant role that results in the geometry.
Okay.
This is actually the essence of algebraic geometry. Okay. We just got a slight taste of what that looks like. Okay. We took just an algebraic equation, and we just manipulated purely algebraically, and we have just did just basic reasoning, and we have arrived at a geometric object like a parabola. That is a prime example of algebraic geometry in action. Okay. Any doubts, Joe?
No doubts here.
Okay, so let's conclude our first. This is very important branch of mathematics. Actually, in the 20th century, mathematics, algebraic geometry had an explosion due to the works of great mathematicians like Grothendieck and people like that. Now, algebraic geometry is at the core of mathematical theories. It's very vast, very advanced, very sophisticated theory, but we are not starting like when you read higher level mathematics textbook, those expositions are very, very cryptic. Okay, it's so condensed and so dense. A sentence requires a day to understand. Okay, but we are not approaching this subject in a cryptic way. We are approaching in an explicit way. We are explicitly writing down all these equations and algebraically manipulating. Okay.
Okay.
Okay, Joe. So let's conclude today. Okay. Let's continue later.
Okay.
Okay.
So.
Okay, Joe.
Okay.